In this video, I want to explain the procedure for carrying out a compass traverse. A compass traverse is a survey in which the positions of points are fixed by distance and angle measurements. So we measure distances and angles. And to measure angles, we use a prismatic compass. The following are examples of compass traverse. We have an open traverse and a closed traverse. In an open traverse, the starting point does not meet the last point. This is the starting point, this is the last point, they don't meet. Now in this traverse, we measure angles or the bearing of lines and their distances. Now we also have the closed traverse, which forms a loop, and in this traverse, the last line, like here EA, returns to the starting point. So this is a closed traverse with 5 survey stations and 5 survey lines. Equipment for compass traverse. You need a prismatic compass which you would use to measure the bearings of the lines and measuring the bearings of offsets. Number 2, you need a surveyor's chain or a steel tape for measuring distances. You also need ranging rods and a field notebook. Before you start taking your measurements, you need to do a reconnaissance survey. In this survey, you walk around the area to be mapped and decide on the survey stations and the lines. Choose the corner points so that the ends are indivisible. The framework lines should run close and parallel to major details that are straight line features like roads, rivers, and so on. After you have done the reconnaissance survey, you make a sketch map of the area to be surveyed. So this is an example of a sketch map, and a sketch map is done or is made using freehand. You don't do it to scale, you just use your freehand. So in this sketch map, we have a school, we have trees, we have the road, the river, houses, and then we have the survey stations which we have fixed in your reconnaissance survey. So we have A here, point A, station A and station B. So we have line AB, which is close to and parallel to this straight feature, the road. Now we have these other points, point C, D, E, and so on. These points, they should be indivisible. Okay, you should be able to see point C from point A, from point E, or from point A, and so on. So that's the sketch map that you need to make. Next, after making the sketch map, which will guide you when you do the measurements, you need to start measuring the framework. The framework consists of the survey stations and survey lines. That is the framework. So we start by measuring the framework, because in surveying we have this principle of surveying from the whole to the part. So before you start surveying the points of detail, we survey the whole, that is the framework. You survey the framework before you start surveying the points of detail. So how do we measure the framework? Now, you stand at one of the points, like point A, and and take the forward bearing of the line AB. So in this case, we are starting our measurements from A to B. So we are surveying line AB. So the first thing you do is that you take the forward bearing. That is the bearing of line AB. So you stand at A and you sight on the ranging rod that is placed at B and take the bearing of line AB. We call it the forward bearing. Now next, after taking the forward bearing, you walk along line AB and count the paces. So in this case, the measurements we are doing here, we are pacing. You walk along the line and count the number of paces and record. We call it pacing. So that's what I'm saying. You walk along the line and count the paces. Now, when you reach the last point, point B, along line AB, when you reach at point B, you also take the bearing of line BA, and we call it the back bearing of line AB. Alright? At A, you took the forward bearing of line AB, but at B, you take the back bearing of line AB. That is, from B, you sight on a ranging rod placed at A and you record. Alright? Now, when you have done that, you will find that the difference between the forward bearing and the back bearing is supposed to be 180 degrees. There may be an error in your measurements, but if you are accurate, the difference between the forward bearing and back bearing is supposed to be 180 degrees. So that's how you survey the framework lines. So you repeat the process for all the framework lines. Right? So next, we need to calibrate the paces. That is, you need to know the length of one pace. Okay, so when you survey, because you are working as a group, a team of surveyors, pacing is done by the same person throughout, because people have different paces. So when you want to calibrate the paces, you need to walk along a known length, say 30 meters, several times. Now 30 meters is the length of the surveyor's chain. So you stretch the chain on the ground so that it is straight and lies on the ground to give a distance of 30 meters, and then you walk along that distance several times. Let's say, for example, the first attempt is 36 paces, then 36, 35, 37, 35, 36. So you have made 6 attempts, alright? Now, the total distance that you have paced, that you have walked on that length of 30 meters is 6 times 30, because you have walked 6 times times the distance of the known length, which is 30 meters. So you get 180 meters. And then the number of paces, you add all these paces, you get it is 215. So the length of one pace is equal to the distance walked, okay, which is 180 meters, divided by the number of paces, 215. So you get 0.837 meters as the length of one pace, or approximately 0.84 meters. So this is what we call calibration of paces. You determine the length of one pace in meters. Now from these findings, you can deduce the scale that you will use to make the map. So let's say that 1 centimeter represents 5 paces. You want to make a map and you decide that 1 centimeter represents 5 paces. Alright, so in this case it means that 1 centimeter represents 5 times 0.84 meters, because the length of one pace is 0.84 meters. So 1 centimeter on paper represents 5 times 0.84 meters or 4.2 meters, which is equal to 420 centimeters. So 1 centimeter on paper represents 420 centimeters on the ground. That means the scale would be 1 to 420. That's how you can deduce the scale for your map depending on the size of your paper. Next is you need to have a table of framework measurements. Now this table will help you to make the map of your framework. The first column is for the lines, line AB, BC, CD, DE and EA. The next column is for the forward bearings. So the forward bearing of line AB here is 48 degrees and so on. Now we also have the column for the back bearing. The back bearing of line AB is 226 degrees. The fourth column is for the adjusted back bearing. So this back bearing, you adjust it. If the back bearing is more than 180 degrees, you subtract 180 degrees. So in this case, it is 226, subtract 180, you get 48 degrees. You get 46 degrees. So we are trying to adjust the back bearing. Here, the back bearing is 283 degrees. So subtract 180 degrees, you get 103 degrees, and so on. The back bearing here is 81 degrees, so you don't subtract 180, but we add 180. So we get 261 degrees. So in this column, we adjust the back bearing by adding 180 degrees if the back bearing is less than 180 degrees, and we subtract 180 degrees if the back bearing is more than 180 degrees. After you have adjusted the back bearing, you also need to revise the forward bearing. So we revise the forward bearing. How do we do it? We find the average of the forward bearing and the adjusted back bearing. So here it is 48 degrees plus 46 degrees divided by 2. You get 47 degrees. So this is how we revise the forward bearing. Next is the column for the length in paces. So your results, you write here the length of the framework lines in paces. You write here line AB, let's say it is 68 paces, line BC is 49 paces, and so on. The next column is the length of the lines in meters. So you convert these lengths in paces into meters. You multiply by this length in paces times the length of one pace. We found that the length of one pace is 0.84 meters. So we multiply these lengths in paces by 0.84 in our case, and we get the following. So 68 paces is equivalent to 57 meters, and so on. Now the next column is we write the lengths in meters, we change them into centimeters using an appropriate scale. So let's say our scale was 1 to 420 as we found here. So using this scale, we convert the length in meters into centimeters so that we can draw on a piece of paper our map. So 57 meters into centimeters becomes 13.6 centimeters using that scale that we have found. So this column is for length accurate to scale in centimeters. Now for us to be able to draw the map of the framework, we shall use two columns. The column of the revised forward bearing and this column of the length in centimeters.